So this is objective 1.2, make a mapping diagram of a relation, and objective 1.3, determine whether a relation is a function. We'll start with a mapping diagram. Now a mapping diagram is just another way of visualizing a relation. Remember that a relation is any set of x and y values, or any set of coordinate pairs or points. Before, we visualized those using either a list of ordered pairs like this, or on a graph, we plotted the points. This is a third way of visualizing those. What we're going to do to make the mapping diagram is take this relation and write the domain and the range of the relation. Remember, the domain is a list of all the x values. So -3, 1, 2, and although I have another 1, I don't write it again. The range is a list of all the y values. 0, 2, 0 again, but I don't write it, and 3. Then I take my list and I connect each element of the domain and range that connects in each ordered pair. So -3 goes to 0, 1 goes to 2, 2 goes to 0, so 2 goes up here, and 1 goes to 3. 1 also goes down there. That's my mapping diagram. The next one, we do the same way. Domain and range, 0, -4, and 9, 6, 5, and -4. Again, connect them as they're indicated in the ordered pairs. 0 goes to 6, -4 goes to 6, 0 goes to 5, and 9 goes to -4. The last one, domain and range, 4, 9, 3, 8, 2, 1, and each of them connects with the neighbor. That's a simple one, but it still is the same idea. Then we're going to talk about objective 1.3, determining whether a relation is a function. A function is a special type of relation. It is a relation where each element of the domain has only one range. So a relation where each element of the domain has only one range. We'll see what that means here looking at these two mapping diagrams. We'll make a mapping diagram for each one here quickly. 1, 3, 4, and 2, 5. Connecting those here, here, and here. And then for this one, domain and range, 2, 3, 6, 7, 1. 2 goes to 6, 3 goes to 7, and 2 also goes down to 1. Looking at these two, we can see what the fundamental difference is between a function, and not a function. In the function, each element of the domain, each number in the domain connects with only one number in the range. This 1 connects with just this 2. The 3 connects with just this 5. The 4 connects with just this 5. Whereas in not a function, the 2 connects with the 6, and the 2 connects with the 1. Not a function, function. It's okay that these two elements of the domain connect to the same range. That's fine. But when one domain connects to two different ranges, it is not a function. Go ahead and flip over. In order to determine whether a relation is a function, when we're given a list of ordered pairs, it's best to make a mapping diagram. So domain and range, -6, -2, 5, and -6 again, 3, 1, and 5. -6 to 3, -2 to 1, 5 to 5, and -6 down to 5 as well. I'm going to look at my mapping diagram. It's a function if each domain only connects to one range. But I see here that -6 connects to 3 and 5, which makes this not a function. We'll try over here. Domain, range, 2, 7, 10, 9, -2, 5, and 0. 2 goes to -2, 7 to 5, 10 to 5 as well, and 9 to 0. Look at each element of the domain and see whether it connects to just one range. 2 connects to just 2, 7 connects to 5, 10 connects to 5, and 9 connects to 0. There's no domain that connects to more than one range. So this is a function. That's when we have a list of ordered pairs. When we have a graph, things are a little bit different. So the vertical line test is what we're going to use, or sometimes called the pencil test. A relation is a function if a vertical line touches only one point. So I'm going to take my vertical line, which in this case is a pen, and I'm going to move it along the graph. And what I'm looking for is to make sure that at no point does the pen touch more than one point. So as I move it along, it's touching no points right now, which is fine. There I see it's touching 1 point. Here it's touching another point, but still only 1 point at a time. There another 1 point. When I get the pen to here, however, I see that now the pen is touching 2 points at the same time. My pen is like an element of the domain, and the 2 points are 2 different ranges. So if we have one domain with 2 ranges, this is not a function. Same thing over here. Take your pen or your finger and pull it across the graph. At this point, we see that this one intersects with 3 different points. So again, not a function. For number 8, if we pull it along, there's no point at which it intersects with more than 1 point, so it is a function. For number 9, we see that here we have 2 points where I'm intersecting. Oop, excuse me. We see here there are 2 points where I'm intersecting, so it is not a function. And here in 10, there's only ever 1 point, so that is a function. And in 11, while there's many points on that graph, no 2 are at the same x value, so it is a function. Once again, that's objectives 1.2 and 1.3. Make a mapping diagram of a relation and determine whether a relation is a function.